Welcome in our class in mathematics, of which today we are going to look at a Cartesian plane and graphs. Cartesian planes and graphs. This is not new. We've seen it. We've once had a Cartesian plane while working on a two-dimension. Graphs where we were able to locate points on a Cartesian plane. We were able to identify what we call the coordinates. Now, there's no difference with what we are going to go through, but this time round, we are going to look at a Cartesian plane and be able to describe what a line is. Just to remind ourselves what a Cartesian plane is, we are supposed to know that a Cartesian plane is simply put on a flat surface with variables of x and y, and these variables have where they intersect. Now, when I say the x and y variables, we have the x and we have the y. We shall look at it in a way that maybe this is the input and y is our output. The point where the two axes meet or intersect, we look at it as the origin, and it is denoted by a capital letter O or a 0. Now, if this is the case, each axis is labeled. From the origin to the left, this one gives us the negative values on the axis. So just to look at an example here, we can have a Cartesian plane like this. So as you have said, this is the origin. So towards the right, we have the scale. Vertical axis, which is the y-axis, we have the scale of y. As you move towards the negative side, we have it becoming negative. It's always good to be able to locate the axis. That's why this line should be clearly known. This is just an illustration. We shall come to illustrate it in a better way. That axis should be clearly known. So this is a Cartesian plane. Now, looking at this Cartesian plane, if I may have a point here, and maybe I ask you to tell me what this point is. What is the position? Let me call it of letter A. What is the position of the point A on this Cartesian plane? From our general knowledge and our previous lessons, you will notice that we were able to read the values here. And while reading the values, we looked at it from the point that we read the x-axis value, which is the input value first, and then we read the y-axis value next. So this is a Cartesian plane. And when you look at this, the y-axis, the x-axis and the y-axis are there. I want us to look at a simple, elaborate classroom properties. Look at the class where you are seated. Try to identify from the way you are sitting, taking the door to be our entrance where we have our origin. Now try to locate approximately how many meters from the door are you. You realize that the way you are seated in this classroom, you find that each student has got different position, whereby we can locate the position the way we are locating the points on a Cartesian plane. So that is how a Cartesian plane helps us in our ordinary situation of real life. So to understand this, we need to have a few areas that we need to understand. I want us to look at basic terms and situations that we are going to use as we go through the Cartesian plane, as we go on and be able to locate the coordinates on the Cartesian plane. So I want us to understand what we call number plane. Now, a number plane is used to represent position in 2 dimensions. It is used to represent position in 2 dimensions. Therefore, it only requires 2 coordinates. I've said it is used simply to show or to locate what we call the position on 2 dimensions. And this particular case, it is only requires 2 points or 2 coordinates. It requires 2 coordinates. Now, at the same time, in mathematics generally, we refer to this as what we call the Cartesian plane. Remember earlier on we had seen and we saw that a Cartesian plane, actually it was named after a mathematician who discovered it. And this mathematician, we refer to him as René Descartes in the year between 1596 to 1650. Now, this Frenchman discovered a Cartesian plane, and from that is where now the number plane of locating a point using only the coordinates came into existence. A number plane consists of 2 straight lines. One is perpendicular, another one is horizontal. So we are saying that a number plane consists of 2 straight perpendicular lines, and these lines, when we say perpendicular, it means they intersect at 90 degrees, or they intersect at right angle. And these lines are called axes. The lines are called axes. You are seeing these 2 lines. Those are the axes. And the horizontal one is what we call the x-axis. The vertical line, we refer to it as the y-axis. The 2 lines intersect at a right angle, and they intersect at an origin. At this point that we call the origin, we label it as capital letter O. And as we have seen earlier on, we have noticed that on a Cartesian, we have got so many lines running along. As I earlier told you, that in this class we shall require you to have the graph paper or a graph book. These lines, it's not that they are faint, but they are acting as a guide. In your graph papers, they are already there. You have got those lines already existing in our graph books. All we need to do now is to know how to locate. So I want to say that we have the x-axis. We should be able to name it. Up here we have the y-axis. It extends to the left and also it extends downwards. The origin with a capital letter O is there. Now here, the vertical axis, what we are calling the y-axis, I want you to be sure about it, and the horizontal axis, which we call the x-axis. There is a use of identifying a point. In this case, I want to have a dot here. If we had the scale labeled 1, 2, 3, 4, and 5, then from this the origin, so this is 1, 2, 3, 4, and 5. The dot here represents what we call a coordinate. This particular dot there represents a coordinate. The dot you are seeing represents a coordinate, and this coordinate can be actually identified by the position it has where it is. And this position is, first we read the values of the input, as I told you earlier on, that x will be our input and y will be our output. So x in this case, its value at this point is first read, and you can look at it when you drop along the guideline until you reach the x-axis, read the value there. You'll find that the value of x here is 2. And then at this point, move horizontally to reach the y-axis. You'll find that the value of this point at y is 4. So a coordinate is written inside the bracket as a number, comma, the other one. That is, start with the x, comma, y, where x is the value along the x-axis and the y, in this case 4, is for the value of y. So a coordinate is labeled in that manner, and I want you to know that a coordinate is simply the position of a point on a Cartesian plane or on a number plane. Now, when we look at this that we are calling a coordinate, this point we are calling a coordinate is simply meant, or it indicates how far from the origin, that is how far from the origin has both either the vertical, on the vertical direction or on the horizontal direction the point has moved. Now when you look at this, this is the origin. We are looking at this point. How far has the point moved to the right? That is on the x-axis. We find it's 2 points. But how far has this point moved along the y-axis? You count 1, 2, 3, 4. It is 4 points. So to locate this point, we are only trying to identify the position of the point by how far it moved towards the x-axis and how far it moved towards the y-axis. That point is what we call the coordinates. Now, that is it about the introduction part of the coordinates. Now, I want us to look at various questions that exist, and we see how we can come up with a way of plotting a Cartesian plane and identifying coordinates on a plane. So we already have our Cartesian, so I'm going to use this to answer the questions that I'm going to write down. So the question reads, plot these points on a Cartesian plane, and the points are A, 2, 5, B, 4, 3, and C, 0, 2. These 3 points, A, B, and C, represents a coordinate. So we have 3 coordinates, and we want to illustrate by plotting these coordinates on a Cartesian plane. So the first thing you need to do is, using either your graph book or your graph paper, and for those who are using just simple squared books, you can also have those boxes guiding us, and we can use them as our units, where we have the boxes being the number of the units. But the better off when you are using the graph book, it will be a bit easier to handle that. Then, first thing we need to do is to come up with the axes, the x-axis and the y-axis. Because if you look at that sheet, it is plain with only boxes. We don't know where the y-axis is. We do not know where the x-axis is. So the first step we take is to identify the position where we shall say this is the y-axis and this is the x-axis. It is always advisable when you are plotting a Cartesian plane, pick at the center of your paper, your page, and that is the point where you'll now pick on one line, and on top of that line, you'll take your ruler and place on top of the line and trace it with your pencil. So we start to identify the x-axis, which is the horizontal axis, identify the center or the middle point of that page, and then draw your x-axis. At the end there, remember to show the arrows. Having shown the arrows right there, this is the x-axis. Then again, locate the y-axis by simply looking at the center of the page again, identify the line you want to use, and label the x-axis. So we are now ready to start. We have the x-axis and the y-axis. 2, it is advisable we identify a scale. It is awkward to pick on a scale that is extreme or a scale that will make your diagram to be very tiny such that you cannot be able to see it clearly. So pick a suitable scale. For my case here, I'm picking one large box represents 1 unit for both vertical and horizontal scales. So having identified your scales, then label it by starting from the origin. And to know where the origin is, it is the point of intersection between the x and the y-axis. So this is where we have our origin. So we pick, I have 1, 2, 3, 4, up to 5, and then y-axis again, 1, 2, 3, 4, 5. Remember, the origin remains at the point of intersection. The next thing is now the coordinate we've been given. Is it possible for us to locate the point on our Cartesian plane? It is very necessary that we first remind ourselves what exactly are we talking about when we have a coordinate named 2, 5. What does 2 stand for and what does 5 stand for? A coordinate to be labeled, we start with the value of the x-axis and then the value of the y-axis. In other words, what I'm trying to say, 2 in this case is the x-axis value and 5 is the value of the y-axis. And as we said earlier, it simply represents, because we are looking at a point, it simply represents how far is that point along the x-axis and how far is the point along the y-axis. That's what the coordinate normally gives us. So we have seen we shall start with the x-axis first and then we read the y-axis. Now we are now ready to go and locate the point A on our Cartesian. The point A is 2, 5. So how do we get our 2, 5? So we first read the value of A. If you look at the value of A, it is 2. Means that this point is 2 units away from the origin along the x-axis. So you'll move, this is 1, this is 2. You'll find that along here, from down here, it doesn't matter, along here is where we have the value of 2. We don't know where it will be, but it will be identified at the point of intersection. Those dots represents the 2. Then we come to the next. It is 2, 5. 5 stands for the y-axis, so we are able to, so we are supposed to identify the 5. So this is 1, 2, 3, 4, 5. As we have said, it's for the y-axis. So 5 starts all the way along this line. Anywhere point you have, it is the value of y is 5. Then the question that comes in, do the guidelines you have indicated have a point of intersection? If they have a point of intersection, that point is the coordinate we are looking for. And you can have that point indicated using a dot. You can have the dot. So that is the point. And then you write with capital letters A in bracket the point 2, 5. That is the point we are looking for. Now, similarly, the way we have been able to identify A is the same way we shall approach and identify the coordinates B and the coordinates C. So the coordinate B reads 4, 3. As seen earlier on, we read how far the point is from the origin along the x-axis. We have said 4. So we look where 4 is. And 4 is where? We have 1, 2, 3, 4. So 4 is along this line. That is a guide to show how far our point B is from the origin along the x-axis. And then 3 is how far it is along the y-axis. So this is the origin. We have a 1, 2, and then 3. So we expect this point to lie along this line. Our point should lie along that line. If you look at that, there is a point where our guidelines are intersecting. The position where they intersect is a coordinate named by the point B, which reads 4, 3. And that point is none other than this point here. We shall write there a B capital, and in bracket we have the point 4 for x and 3 for y. So we have been able to locate the point B, 4, 3 on our Cartesian plane. Similarly, for the last one, we just ask now, I think we are comfortable with identifying the point, so we can easily go through that. The point is 0, 2. 0, 2 means y is our subject, because y crosses x axis at the origin, and the origin, the value of x is 0, which means that the position we are looking for from the origin of the x is not any movement, but it's along the y-axis. So we are expecting to move along this particular line to get the value of 0. Now, for 2, it is how far the point 2 is from the origin along the y-axis. So this is 1, this is 2. We'll expect you to move along this. Now, you realize that the point that is coming up is this point here. That is the point C, which is 0, 2. So this is our Cartesian plane. This is how we draw a Cartesian plane on a paper. This is how we locate the coordinates. And the approach, we must always use the guidelines. It is always advisable you follow the guidelines. Don't just pick on the units anywhere in between the boxes. Now, the next question So from this table of values, we have the rule output is equals to input plus 1. And using this rule, complete the following table. This kind of problems, you have already seen them earlier on, so we can be able to do it mentally without going into real calculation. So the first part we have is when output, and remember output is our y, and our x input is x, then plus 1. So that is the equation that we have. So they are told, find y when x is 0. So when you have x 0, 0 plus 1 is 1. So you find that when x is 0, y is 1. When x is 1, it will be 1 plus 1, which is 2, so y will be 2. When x is 2, it will be 2 plus 1, which is 3. And when x is 3, it will be 3 plus 1, which is 4. So this is our table of values, giving us the two variables, that is the input, which is our x, and the output, which is our y. But then now, having had this, our second part of the question is asking us to plot each pair of points. To plot each pair of points on a graph. We want to plot each pair of points on a graph. So the second question reads, So plot each pair of points in the table to form a graph. So we are going to reserve this, and then we shall use the values that we have here to design or plot our points on a graph. So I'll have our x and our y. When x is 0, 1, 1, 2, we have 2, 3, and 3, 4. So when they ask you to plot, remember it is about a graph, so you are supposed to always get your ruler, get your pencil, open a new page of a graph paper or in your graph book, and you start identifying the correct places where you locate the x-axis and the y-axis. I had demonstrated that earlier on how we shall get into that, so we shall just move straight to the question. When you look at our table of values, it can tell you the extent to which your scale will stretch to. Now, as we saw earlier on, the input is taken to be our x-axis. Therefore, the input here, we shall choose a scale correctly as per the x values. The input is here, 0 to 3. So we expect this side at least not to go beyond 3. That is what we expect. And along the y-axis, we shall move not more than 4. So as we choose our scale, it is 1, 2, 3 for x, 1, 2, 3, 4 for y. So this is our scale. I said on the x we have 0, 1, 2, 3. So this is our 0. This is our 1, our 2, our 3. And along the y, 1, 2, 3, and 4. Now, this question here, each value of input and value of output brings or creates what we call a coordinate. So in other words, here we have the following as our coordinates. First coordinate is 0, 1. Second coordinate is 1, 2. The third coordinate is 2, 3. And the fourth coordinate we are going to plot is 3, 4. Those are the coordinates we are going to plot. So the 4 pairs of coordinates. Now, coming to our graph, we want to identify those points and put a dot or an X where those points are. The first point is 0, 1. 0, 1 means that the X axis, that position we are looking for along the x-axis has moved 0 units. So it means it will remain along the y-axis. But on the y, it has moved 1 unit. So the first point is here. Second coordinate, 1, 2. X is 1, y is 2. When you follow it up, it will meet here. The third point is 2, 3. 3, 2 for x and 3 for y. It will come here. And the fourth point is 3 for x and 4 for y. So this one will come at this point. Now, because we have plotted the point, sometimes it is good to label those points so that we can know that you know that this point is the A, or so on. So if it was necessary, we would actually assign maybe a letter on every coordinate. Maybe the first one would be our A, our B, our C, and D, so that we know where A is, where B is, and where C is, and so on. So the A is here, so we can give it here. This point here is our A with the coordinate 0, 1. This point here is our B with the coordinates is 1, 2. This point is our C with the coordinates 2, 3. And the last point is our D with the coordinates 3, 4. Sometimes it's good to label those coordinates so that we can know that you as a learner knows exactly what you are doing. Remember, it is very, very important to observe the rule, and then also very important to fill the table of values. And from the table of values, we identify which one is the output and which one is the input. The input is our x-axis and the output is our y-axis. From that table of values, we've been able to locate our coordinates and transfer the coordinates on a graph. And here we are with our number plane. Now, I want to say this. Not always that we must have a table of values so that we can come up with a Cartesian plane. Sometimes we can have a Cartesian plane and then give the coordinates, and then from the coordinates we identify what was the rule that was governing that particular table. Now, from this, I want us to answer the following question. Now, this question reads, which of the following is correct? A, 2, 4, B, 4, 2, C is 4, 2, you have D is 24, E is X equals to 4, and Y is equals to 2. So which of the following is correct coordinates, is correct for the coordinate B? Now on this Cartesian plane or on a number plane, we have the big letter B located somewhere, we have a dot, we want to locate that point. They have given us various points around here. Which one is the correct point for this part we are calling B? So here, look at A. A is 2, 4. Starting with the x-axis, A is 2, and then 4. A is 2. So do we have a dot there? We do not. So this is false. It does not represent the B we are looking for. Look at the second one. It's a coordinate. It reads 4, 2. Value of x is 4, and for y is 2. So we have 1, 2, 3, 4. 4 is here and 2, so this one intersect at B. So this one is true. The third one is reading 4, 2. Just a minute before that. Yeah, the second one is 4, 2 without the bracket. Let us not even waste time to read 4, 2. A coordinate must be inside the bracket, so this one is not correct. This one is false. Reason because it does not have the brackets as what is required about the coordinates. The third one is 4, 2 inside the bracket separated with a comma. That is the one we are looking for, so that one gives us the true information. And the last one, I don't know if they wanted to write 2, 4 or they wanted to write 24, but the moment you have it in bracket without a comma, then that one is taken to be as one number. So this is 24, which is even outside the scale of the graph that we have. So again, this one is false. Now for the last one, they are telling us that x is equals to 4 and y is equals to 2. Now take a note that what we are looking for here, B, is the coordinate. We are looking for the coordinate. And if we are looking for the coordinate, we said earlier on when we were introducing the lesson that a coordinate is written in form of x, y, and all of them in brackets separated by a comma, which means if we want the coordinate should be in this form. It is true the value of x is what is the first one, the value of y is what's the first one, but it is not written as x is equals to maybe 4 and y is equals to 2. It's not written like that. That is not a coordinate. This one you're looking for what you call the roots or solutions over the pronumerals or of the variables. So this is the right procedure. So by saying that, then we say this one, this statement here is not going to give us the coordinates as much as it's true x and y are values for this particular point, but that is not the format for writing down the coordinates. So I again strike out this one and say this is false. Let us write the correct format of writing the coordinates. Now for your assignment, and you can refer to it later on, you can check, or you can use a laptop, the spreadsheets, and do the same when you're using spreadsheets, the Microsoft Excel. You can still plot the Cartesian inside there. So at your time, I want you to look at the following tables. You will complete the tables using the given rule, and then from there you plot the graphs and the coordinates using your computer on a software called Microsoft Excel or a spreadsheet. So this question, you'll do it as your homework. For the given rule, output is equals to input plus 2, copy and complete the given table of values. Input and output. We have been guided, therefore they are given us input as our x and output as our y. So these are the values, respective values we are going to have. And then now, having said that, then we move ahead and now look at, when you fill this table now, then either using a spreadsheet software or a graph paper or a graph book with a pencil and a ruler and choosing the correct scale, from the each and every values you have here, plot that point on a graph. So that is it for our today's class and on the chapter called Number and Algebra. Having taken this one down, I want us now to approach this question and resolve it and work out, putting in mind all the instructions we were given while plotting points on a graph, and putting in mind exactly what requires us to do when we have a rule like the one we have here. So first, before we move on, we need to have this table filled. So in our solution, having been told x, input is x and output is y, so I'm not going to have input and output, I'm going to use the letters x and y. So the rule will change and say y is equals to x plus 2. Y is equals to x plus 2. And by substitution, as we saw earlier on, where we have the values, we substitute respectively to the values of x and we complete the table using the rule that we have. So the first one is when x is 0, then y will be 2. So we shall have 2 here. The second rule will be when x is 1, then y is equals to 3. Have 3 there. The third one, when when x is equals to 2, so we substitute 2 here, then plus 3, it means that the value of y will be 5. So we bring a 5 here. And finally, we have when x is equals to 3, then we substitute where we have x the 3, we shall have 3 plus from the rule 2, then we shall get, we need to correct something before that here. As we do this, the constant is 2, so this is y is equals to, the value of x is 2, plus the value of y, the constant is 2, this one gives us 4, and the last one, it is 3, 3 plus 2 gives us 5. So that is what we have. So we fill in the values. This will be 2, 3, this one is 4, and finally 5. So having said that, then we ask ourselves what will be the respective coordinates for each given part. And this one requires to be reserved. So I'll bring our table of values on the side here. So the table is x and y. We have our x and our y. So from here, when x is 0, y is 2. When x is 1, y is plus 2, that is 3. When it's 2, this is 4. When it's 3, this is 5. So that is what we have. And this is what is going to guide us and know what will be the extent of our Cartesian or scale on the x-axis and on the y-axis. Having had this information now, it's time to transfer it in our spreadsheet or simply on our graph. As I said earlier on, you are guided by your coordinates. Do not put your coordinates at your own point. So the coordinates, we shall be guided by the table of values. So you realize that on the x-axis we are going from 0 to 3, so it will be easier slightly, is 0 to 3. And now on the y-axis is between 2 and 5. But because the origin remains the origin, do not start from 2. You have always to start from 0 as you move on that way. It's always good to label your axis. So this is our origin. This is our x-axis. This is on the negative side. It's allowed to go on. This is our y-axis. Now the labels, this is our 1, our 2, our 3, 4. Y, this is 1, 2, 3, 4, 5 for x. So if this is the case now, then to plot the points, the first coordinate from the table of values is simply 0, 2. And we can have 0, 2 as here. Put a dot. Next is 1, 3. This is 1 and 3 is here, so this will be here. And the next is 2, 4. This is 2, this is 4. This point will come there. And lastly is 3, 5. This is 3 and this is 5. This is going to be here. So we have the points. As I told you earlier on, it is always a good when you label your points so that you can know when you are plotting your points whether you are doing it correctly or you are doing it wrongly. So these are the points that we have, and we should be able to plot them correctly as illustrated here. So for your work now about filling the table of values, we've done it several times. We should be comfortable with doing it. So for your work, let us do the following. So on your homework, for the given rule, output is equals to input times 2, copy and complete the table of values. And the table of values, we have it here, x and y. Then later on, for each pair of points you've gotten in the table of values, plot to form a graph. So this is for your assignment, use a spreadsheet or a graph to do this particular question. Thank you.